How's everybody holding up? It's a long day, right? All right, so we're going to talk for the next 40 minutes or so about dependency management. How many people have some sort of dependency management strategy right now for their projects? Yeah, everybody's hand should be raising. But it's a complicated topic to talk about. It's a complicated topic to implement. But the cool thing is things are getting much, much better. And I'm going to show you 4 solutions today, a couple that I've tried that I'm using, and we'll show off a little GB, and we'll show off the new vendor flag. And you can see how things are getting much better in the world of dependency management and Go. So, like I said, it is a complicated topic, and I'm not going to get into all the minutiae around it. There is a mailing list called GoPM, and the GetGBIO website does a really great job at explaining some of the problems that we have today around dependency management. But there are a few things that you have to be thinking about when it comes to this topic. And even before you start your project, before you write that first line of code, I think this is something that needs to be on your radar screen. Now, how are you managing this source code in your version control system? How are you branching that code when it's time for a release? How are you handling bug fixes? Those things need to be in place. And then how are you structuring the project itself to support that strategy and to support the dependency management as well? So I'm going to show you 4 strategies. What I call organization vendoring was the very first strategy that I attempted to use about a year ago. I still have one project in production that's using it. It does work. It's not my favorite anymore, but it does work. Then I'm going to talk about project vendoring. It's what I'm doing today. We'll see how that works and some of the problems and advantages of that. And then we'll look at GB and that new vendor flag in 1.5. So I've got a small project. It's a simple web API project, but it's using all of these packages. So these are the packages that I need to vendor and make sure that every time I produce a build, right, I always get the exact same binary. That's the whole idea of vendoring, right? We're going to take this code, and we're not going to try to fetch it from these particular URLs. We're going to bring this code into our projects and manage that ourselves so we can have this consistent build. So I've got a few constraints that I've put on myself. One we just talked about. We need to vendor each of these packages into our own projects. We have to place each of these individual packages plus any imports that these packages bring in. We've got to bring in as well. So we've got to look at everything that's being used. All right? And I'm making sure that after I do this, I'm removing those packages from my traditional Go path workspace. I can't tell you how many times I've made a mistake, but the package is in my traditional Go path, and then when I go to build it, it doesn't build, but it always builds on my machine. So try to keep my Go path, my traditional workspace clean. All right. So this is the first approach that I tried. Like I said, I still have one project, production level project, that's using this. The idea was to go into GitHub and create an organization for the project. So this project was called FinApps. So I went to GitHub, created a FinApps organization, and then I took every dependency that was in my project and created a repo for it. And so if I'm looking at disk here for that project, I made up a silly domain, I could have been github.com, but I'm using DVCS. Org would have been that FinApps. That's the name of this project. I've created an organization. API is the code that I'm writing. So any other packages that I'm writing are in there. I've shown you where my main.go is. And then I created all these other repos. And I took out the fact that where they were in GitHub and those other things, and just brought in the actual packages themselves. Now I have to keep track of where those are, and you have to manage that anyway when you're vendoring. But this really gave me a very nice, clean tree to work with. So if I'm looking at one of those files of the packages that I wrote under API, users.go, there's the import to the handler, to the app package, right? You can see where that is in the tree there. And the import is pretty nice and clean. It's small, that's manageable. We can work with that. But now when I want to use this validator package, right, I want to use it inside this modules file, code that I'm writing, I can't use it by that import name. I have to go in and rewrite all of those import paths to point back to my organization. So this is requiring rewriting those import paths everywhere. So every dependency that I bring in. And every time I reference this, I have to reference it from inside the organization. But these import paths are pretty small. They're simple. Everything's tied to the organization. So if I were to just look on disk, and this was the only project I was working on, I should just see, right, the dvcs.com/org, and I've got everything there in one place. So it's easy to work with. So I have all of this on disk, so I want to build some stuff as we go along, just so you can see it as well. All right, so we're talking about the org project, just so you can see. I've got this on disk right now as if this was already in use. So I'm just doing a go install. It builds. I can now run that from my bin. Program starts, no big deal. And everything is working, everything is fine. I'm just going to remove this API. Not much of a show here, but things will get better. All right. So here's the list of disadvantages on using this approach that I realized over time. I started ending up with a really large number of repos that I had to manage in that GitHub organization. In fact, this project was using BGO, and BGO really grew out of control at the time. So when we were updating these dependencies, it felt like almost a nightmare of just constantly adding repos to GitHub. We had to rewrite those import paths. There was no way around that. It's really tedious to set up the first time. But I think one of the things that really, really failed here was after we produced that binary for production, we had to go and tag each repo, right? And so we end up having this tag that is in time, but it's like in all this different space. And so it just never felt really comfortable with this approach because I just really I realized at the end of the day that the code was just all over the place. And really, this only works if you're managing one, maybe two binaries anyway. Because all of a sudden, if you're managing much more than that and you're building binaries at different times, oh my God, like which package was for this biname when we tagged this? It really didn't work. It was an experiment that seemed really good at the time, and it didn't work. And plus, you always have the opportunity of making mistakes, rewriting those import paths. But there were some advantages. The Go command and all the existing tooling that was out there and our editor plugins, we're using Sublime, worked immediately out of the box. We didn't have any issues with that. All the code was in one place. We could just look at that organization's block of code, and we saw everything that was there. The rewrites weren't so bad. Those import paths were still fairly small and manageable. And really, once we set it up, only one member of the team had to worry about maintaining it, and there really wasn't a burden on the rest of the team. But I don't think I would ever choose that option again. It was my first time thinking about this and finding a way that seemed to work with everything that we were doing. So today, this is what I'm doing now. And I just call it project vendoring. So the idea is that instead of having this organization with all these repos, where the repo is each dependency, we're going to vendor the dependencies into the one repo, into this one project. So this project produces a single binary that we can manage. If I've got multiple binaries, well, they all have the packages that they're vendoring. That's what we're doing today. All right? So here's that same project, but this is how it would be structured now on disk. And there's different ways you can structure this. This is how we're doing it. So we've got our project. We've got project. Here's the repo for this. This binary is going to be called API. We create off of there a source and a vendor folder. In the source folder is where all of the packages and stuff that we're writing go. So anything that we're writing goes there. Everything that we're using as a dependency falls right under vendor. And we maintain that URL for each dependency, whatever it is, right under there. And we maintain our own little vendor file that gives us information on commit IDs and stuff. We do that manually. All of that could be scripted out too. All right. So if we look at that same file, when we were looking at organization, dependency manager, the first thing that I did, that was what my import ended up being, that /org API app. But now, when I vendored this at the project level, you can see how that import just grew a little bit larger. Not too bad, right? I've added that source folder. It's not horrible. You can see where that falls into the tree view. But this is where I get depressed with this solution. Look at the length of the import path now from where it was before. Look how long that is. And I've got some even longer ones in production level code. And that it always just tears me up when I see that. It's just the nature of doing it this way. So I went from a fairly simple import, right before, to now this really long import that has to go all the way from the beginning to the end because we're maintaining both URLs in there. And I've got to go back in again to all of the code that is vendored, where it used to look like this before, now it all has to look like that. So yeah, I've got to have tooling and scripting to go in and rewrite all these imports, and I got to make sure I don't miss one. But if I do all that right, then everything works really well. And so we can do that as well. We can go look at this project folder. There's that API folder. We can see here that I've got that source and that vendor. I can build this without a problem, except I have a problem here because it's the demo gods. Let's see. Oh, yeah, that should have worked. So I should have built that without a problem. We'll have to look at that later. And I'd be able to run that. So this is really what I'm doing today. All the production projects that I have right now are following this structure. The disadvantages are that we end up with these really long import paths. And I love Go imports. I mean, it's like one of my best friends. But what happens is Go imports ends up pulling in always whatever's in my Go path, and then I always forget that I've got the wrong import in the wrong place. And that drives me nuts as well. So there is some compatibility issues around some of the other tooling. We've got to, again, rewrite those import paths, and there's always a chance making mistakes, and we usually don't catch those until we try to build something, test something on the CI server. But there's a lot of advantages as well. I still have a lot of compatibility with the Go commands. Most of the tooling, the editor plugins are all working. All the code is in that one repo. I mean, this is so much easier to set up and manage than that other solution, that organizational rendering. The entire team doesn't have a problem with it. And now what's really nice is when I tag this it's all now in that same space and time. In fact, now I could have a strategy where I can just create a release branch off of that and say, okay, this is 1.0, and we have it. And all the code is there in that one space and time. That's a really big advantage. And again, with some simple scripts and tooling, it's easy to be able to just copy stuff into that vendor folder and do those rewrites. All right. Now, both of these solutions exist today because primarily we can't trust GoGet in terms of what it pulls down every time we call it. Right? The import statements don't really, well, they don't have version information on them. And that's one of the big problems. I can call GoGet in 5 minutes from now against that same repo, and something could change. And the compiler looks at that import statement really as a location on disk, right? It looks at it as a location on disk, but GoGet is looking at that same import as a URL to go fetch code and to place into your workspace. So GoGet also really doesn't understand vendoring. And there are some really great tools out there that are trying to solve this problem, but this is the problem that they're trying to solve. Eventually, they're sitting on top of the Go tooling, they're sitting on top of GoGet, and they're trying to make it so GoGet doesn't, at the end of the day, burn us. And in thinking about this, I realized that when I was thinking about these solutions, I kept saying to myself, no matter what solution I employ, no matter what it is, I have to be compatible with all the Go tooling. I can't walk away from it. But I started to realize that, the language and the tooling are really two separate things. That I don't have to feel like if I walk away from some of the tooling, I'm walking away from Go. I'm not walking away from the language. I'm just looking for a way that works for me to be able to build this code consistently every single time. Right? I'm not walking away from the language. I'm just maybe walking away from being compatible with GoGet. I mean, if I printed out here the go install command for that project, and I wouldn't expect anybody to go to this level, and I'm running 1.5 on my machine, but what is the Go tooling doing? It's setting up some folders, it's calling compile, it's calling link. I mean, we're still using the compilers and the linkers. So even if we're not using the front-end tool, we haven't abandoned Go. And when you can come to that realization, I think you can really open up your mind to some new solutions that will work. And this is where GB comes in. So GB is a new tool, and it's helping with this reproducible build problem. It takes this approach that you're producing a binary, and all of the code for that binary should be packaged together as a project. And what's even more brilliant is that that workspace you're creating for this project shouldn't be restricted to just some single workspace like we have today, like have your Go path. That workspace can be put anywhere you want on disk, it shouldn't matter, and you can build that wherever it is. Right? And I think it's a tool that shows how when you separate the tooling itself from the language, you can really come up with some pretty elegant solutions around this problem. So here's the structure of my GB project on disk. It's very similar to what we had before. Off of my repo here, API, I've got my source folder. I've got all the code that I'm writing. I have a vendor folder. The one difference here is I've got that source folder under the vendor folder. And that's now where all of that code is. GB is going to produce a Go path on the fly underneath based on where those source folders are. And when it does that, things get really, really simple. So at my project level, remember when I wanted to use the app package, I had to import all of that. But now in GB, I just have to import app. Because the workspace is where the API folder is. I don't have to think about how far deep I am from some particular Go path. This is where my Go path is. So it finds it, and all I have to do is say, oh, I'm going to import app. And the same thing for the code that I'm vendoring. See, I don't have to rewrite my import paths anymore. That's brilliant. I can just put the code I want to vendor under the vendor source folder and import it as if I was importing it from its original location. All of that, those problems and mistakes and headaches that I had before, they go away. Again, I don't even have to go into any of the vendor packages and rewrite those import paths. No more rewriting of import paths at all. All right. So this is my GB project. When you do a build in GB, it will create those bin and package folders at the root of your workspace. There's my source and my vendor folder. So I'm going to do this GB build here. That was really fast. But it built that. It started my server. GB will always put that binary in that bin folder for you. You can see how fast that was. I can GB build minus V should give us a little more. You can see all the quick things that GB. Let's do the following just so we can look. Let's remove, what is it, minus. Oh. What is the remove command to remove package here? Remove minus RF or something? All right, cool. Let me see it do a little bit more. So you can see GB is producing a Go path underneath. It's finding all of the packages there that have to be built. It builds that. It puts it inside that bin folder. And then we can run. And everything is vendored inside this one project, so we have a reproducible build here. All right. Now I want to show you something else that's kind of cool with GB. GB, the tool itself, is about building and testing and those things. And it now has a plugin environment. Anybody can come in and build plugins for GB. So someone's come in and built this vendor plugin for GB that will make it easy for you to bring that code back into that vendor folder. So what I'm going to do is come in here, and what do we got here? I'm going to remove that. All right, so I've removed this dependency, one of the packages, from my vendor folder. So this is just double check that it's gone here. And yep, it's gone. I should have seen under Blue Sun Corp that validate package, and I don't have it. All right. So since we know it's not there, I try to do a build now, and it fails, right? I don't have that dependency in my folder anymore. So now what I'm going to do is I'm going to call the GB vendor plugin. I'm going to ask it to go fetch that dependency. It's going to go fetch it, and it's going to put it into the vendor folder for me where it's supposed to be. Sweet. It's all done. If I look at my tree again, there it is right here, validator. It's been put in, which means I can do another GB build. Oh, did it again, didn't I? Isn't that great? So there we go. It built again. It didn't fail. And now I have that binary, and I can run it. So that's really, really cool stuff. All right? This is not sitting on top of the Go tooling. Okay, the tool is using the compiler and the linker and the assembler, okay, underneath, but it's a brand new tool. This shows what happens when you can separate the tooling from the language. You can now take a whole nother idea and step around solving this problem. The code now to work with is really clean. Those import paths are super clean. And the vendoring tool makes it easy to just vendor the things in that you need. Now, there's a couple disadvantages. It is a brand new tool. Not all of the features that are part of the Go command and that tooling exist yet. The biggest one for me is the race detector. I mean, I live in the race detector. I'm running it all the time through my tests, and I don't have it right now. And you might have to change some of your workflows depending on how you can set up your editor and those other environments you're working with. Again, it's because it's new. But look at all the advantages of GB. For me, it's the holy grail because I don't have to rewrite my import paths anymore. I mean, that alone is just brilliant. I can put this project anywhere on disk, anywhere I want, and GB will build it as long as everything is there. And finding new ways every day to make GB more compatible with the editor plugins with some minor workarounds. We got that one project repo again for all the code. This is really not tedious at all to set up with those plugins. Makes it really easy for the team. I got that single branch again tag every time I do a build. Just really brilliant. All right. One of the ways I solved some of the tooling issues is I use Sublime, and Sublime will let me create a project file. And so in the project file, I set up a hard-coded Go path in there. So when I load that GB project up, I'll have a Sublime project for each one. So I'll still have a traditional Go path, which allows all of the other Go build tooling, all the other Go commands to still work if I want to run that race detector, if I want to do those things. But over time, those things will be brought into GB, and I'll have less dependence on it and a little more freedom to not have to do that. All right. So that's GB. I wanted to show you the new vendor flag in Go now. And I am really excited about this. Really, really excited about it. And I'm going to show you a little demo here, and I really like what I see. So let's go back and look at this now. Okay, so we got this new flag. It also solves that problem where we don't have to rewrite import paths anymore. Brilliant. All right. And there's this promise now that all the existing tooling will work as it does today. And in fact, GoDep and GoVendor and others in the community are already starting to write support for this, and it's already there. I'm going to actually show you GoVendor working with this new flag as well. So here's my project structure. I'm back to the same structure I've been using for my project level vendoring. I've got my source folder with all the code that I'm writing. I've got that vendor folder with all the code that I'm vendoring in. Same exact structure. So in GB, when I was in GB, I just had to say app to import that app package from this source code file. Now in 1.5, I still have to use that long, but that's not that long. That's no big deal. I'm really happy with that. I mean, GB made it brilliantly simple, but that's just fine. I mean, that's what we're doing today. We could see how that lays out in the tree. And just like in GB, we don't have to rewrite any import paths anymore for anything in that vendor folder. So all this is the same, just like in GB. Again, this is huge right here, not having to rewrite those import paths. All right. So what I'm going to do here is come over here for a second. Okay. So I should have reset this. We're going to set this back to 0. This is the Go environment call. Let's export this back to equals 0. And this is the flag that we're talking about. And just leave it like this. Okay, sweet. So this is that new experimental flag right here. All right? And by default, it's not going to be set. So right now, it's not set. So now if I try to build this project without having that flag set, Go is working just like it does today. It's failing. It's telling me it can't find any of these dependencies, because remember, I've removed it from my core Go path. It only knows right now to look there. Okay, no big deal. Let's put this back to 1. Now it's back to 1. I'll run that same Go install, and the errors go away. I now have that binary based on what was in the vendor folder without having to do any rewrites whatsoever. And this will run. Really brilliant. Really excited about this. And I like that it's an environmental variable right now. So nothing changes for me. I can still just call go build. It's not go build minus something, right? It's just there in the environment, and it can be set when it's needed. Now, let me do this. I'm going to remove that same package from that vendor folder for this project here. So this should be gone after I run that. Sweet, it's not there, right? We just have the assert package. Okay. So if I try to run this again, this better fail, right? Sweet, still fails because that dependency is not there anymore. So this is brilliant. I'm going to call go get like I normally would. Now go get's going to take this package, but it's going to put it into my standard Go path. So it's out there now in my standard Go path. Go get isn't doing anything different than it used to do. There it is. It's going to be out there. All right. If I look in my standard Go path, there it is. It's the only thing I have there under that Go package in. And now let's do the following. I'm going to come inside my project here. This is my Go project, my 1.5 Go project. And I'm going to ask Go vendor to look in my Go path, find this dependency, and bring it in to my vendor folder. And if that worked, then brilliant. There it is at the top. And just to make sure that we're not leveraging anything out of my Go path, let's remove it from the Go path. So that should be gone. Sweet, gone. And now with everything back in place, it all builds. Brilliant. I now have the ability to have a single repo with the entire source code for my entire project. I don't have to rewrite import paths anymore. Brilliant. Go vendor is already here today to help you vendor stuff into that vendor folder, just like I showed. And we have the promise of the future of if everyone sees this, rallies around it, we build some tooling around it, this could be what I think a really great and permanent solution. We can stop talking about this for once. Now, that being said, GB right now also is an incredible tool. It's here today. It's actively being developed. It's got a lot of legs, and you really should be looking at it too. The idea that we can put that project anywhere we want on disk, the fact that the import paths for the code that we're writing are even simpler, and all the plugin development, and you as a community could get behind that tool and add all the plugins that you need and help develop that to whatever it is we decide as a community we need for dependency management. I had no idea when I asked to give this talk that I'd be up here going, oh my God, we've got 2 great solutions right now. Like, that was not the conversation we were having a month ago. But now it's the conversation we're having. Right? There's this light now at the end of the tunnel, and it's up to us to decide what direction we want to go in. Both can live at the same place. right? You can still have both tools, but we can now really decide and rally behind this problem, which really is starting not to be a problem any longer. So my only disadvantages here for the 1.5 right now is not all the Go commands are compatible yet. Building, testing is working. That Go install is working. We still got to get the community tooling to come up to speed with this as well, but you're already seeing that happen. And what's nice is, just like I did in GB, I can still go into Sublime, though, set my Go path the way I was doing it at my project file, and still be able to leverage all the Go tooling anyway. So it's not any more of a different problem than we have with GB. So it's nice. There's solutions there in the interim while we figure the rest of it out. But I love the list of advantages. No more rewriting import paths again. Compatible with all the editors, which is important. And all the other things that we talked about that were advantages for GB as well. All right. So I'm really, really excited about the future now as it relates to dependency management. The projects that I have today that are using that second solution that I showed you, they're going to probably stay like that for a little while. I'm really excited about this new vendoring flag, and I definitely have plans to use it on my next project. And GB. We're working with both of them. And we're just going to get a better feel for which one is solving our problems right now the best, and giving us the flexibility and the productivity that we need throughout the entire life cycle of the products that we're building. Thank you.
Any questions?
Yeah, just really quickly, you showed a tool called GoVendor, all one word. Is that just a third-party tool? The GoVendor
That's a third party, yeah.
Any more questions?
On your first slide, you started with 4 different strategies, and you worked through them. And the first 2 strategies got you into deep water because you had to rewrite your import statements. And then you solved that problem, and you got very excited. But if you hadn't caused that problem in the first place, then you wouldn't have had to solve it. So I just wonder, because you miss off there a strategy that other people use, projects like GoDep and Glock, where they, instead of importing things into a separate vendoring folder, you just import into a single source folder. Certainly in the case with Glock, you have a text file which records the versions that you're using. And each developer does a checkout of a fresh clone of the repository of the source code, which gives them the source code for their own project plus this text file. The Glock tool, Glock sync on that, fetches all the dependencies at that particular version, but they're not in the source tree. So that's a different strategy from what you're doing there. They don't put the source code into the same source tree. But they do get the same benefits, because you don't have to rewrite imports. It works with all the existing tools, and it's very, very simple. So I just wonder why you didn't cover that in this talk.
Right now, this talk was more around vendoring and how I've been vendoring things. And I think the community, for the most part, has said that vendoring is probably the safest way to go as it relates to these dependencies. I've never been a big fan of having that file that has those commit IDs and then pulling those down that way. I mean, I like the idea that all the source code for this product is right here all the time, and I can manage that.
But you wouldn't have that with a traditional project like a Java project. You don't have that kind of thing. So in a Java project or whatever, you have Gradle. You say Gradle build. It goes off to the internet and fetches megabytes of downloads of jar files. You don't then put those into your source tree. That's not the way those things work. So I don't see why this should be different. You haven't justified that.
Yeah, I don't know if I have an a 2-minute answer for you on this one, so we can definitely talk after. But I understand what you're asking.
Yeah.
There's lots of solutions here. I've shown you one that I tried originally and all the problems that it had. I showed you the one that I'm using today and 2 new ones that are out now that I think have a lot of promise. But this is just 4 solutions out of God knows how many are out there that people are trying. Right?
So regarding the solution that you were proposing, the problem with that is that you're still depending on the projects that you're using to be there when you're going to try to get them. So if you're saying, oh yeah, I'm using this commit ID from this GitHub repo, and then that GitHub repo disappears, then your code is gone. So you still have to handle these kind of problems. GitHub repos disappearing is unlikely? Okay.
Well, let me tell you a story about that. I put a package out a year ago for one of my blogs. Some silly, stupid API that made a Google call for Latin long. And I was cleaning up code because I was like, oh my God, this code is so bad, I gotta clean this code up, right? So I'm doing all this code cleanup, and I don't know what happened. But an hour later, I get an email from somebody saying to me, what happened to this project? And I was like, what are you talking about? It's gone. And I looked, and I deleted the source code file from this package. I had no idea. And I had no idea anybody was using it. And I quickly put it back and apologized 10,000 times. So that can happen just by accident if somebody's moving too fast like I was that day. Boy, my stomach just dropped when I got that email. It's crazy.
I see the advantage of having all the vendors' files in the same repository, but what's the way of tracking changes and updates for those libraries which are already checked out? Is there a solution for that?
So both Go vendor and the vendor plugin produce that file that you're talking about. And if those items are in the file, then it's going to let you know what's going on. So those plugins already and the other tooling do that. If you're not using one of those tools and you're doing your own scripting, then you've kind of got to build that in. I think it's a good idea to have that vendor file or manifest file just so there's some sanity around what commit you're using, but not to use it as a way of saying, let me pull this down, just as a way as a record of what you did vendor and when.
I'm curious do you know if either of those tools support vendoring at an organizational level, such that I don't need to push the same dependencies to 9 different service projects? Like,
so you
want the same version of the same dependency for your entire organization, so say they can talk to each other, services.
Yeah, but you're still leaving yourself open for somebody to go behind the scenes and change that repo on you, right?
No, I meant it would obviously be in a repo you control. Just that you don't have a copy of this dependency in every single one of your organizational projects. It's like a single copy per organization.
If you feel comfortable using the canonical URL, which will point to your own server, to that own thing, then I guess you're comfortable, right? But it's still a dangerous game to play because at any time somebody can come in and make a change and you now no longer have a reproducible build.
I guess, but you could also say it's a big, massive pain in the butt to manually go fetch a bunch of different services to update their dependencies.
And so that's where this tooling comes in, like the GB plugin that we showed, the vendor plugin, and Go imports, and there's a lot of other really nice tooling out there. So it's risk and reward, man. If you care about your product, you've got to be vendoring here, and you've got to be managing these dependencies.
Hi. So my take on this, my background is with Debian and in the past with Perl, with CPAM, and there's an interesting thing going on here where I wonder if you could speak about the nested nature of these dependencies, where a library can have its own vendoring, and you might end up with 2 copies of the same third-party library used in your source. And are there risks with that? It's a similar point to the 2 copies in an organization. I think there are different takes on this. I think there are more than one solution. The ones I'm familiar with are the sort of the NPM solution, where you do nest your vendoring, but then that contrasts with the Debian approach if you've got a single version in the archive, or the CPAN approach of all your libraries try and use and try and work with the latest version of any third-party package, and that's sort of enforced socially through tests and so on. Sorry, I'm talking a bit long about this. I don't know if there's a single solution that's going to satisfy everyone and Google. Anyway.
The only solution you have is you can only have one version of that dependency, no matter how many other dependencies are importing it. And if you're unlucky enough to have 2 dependencies that are importing different versions of the same package, you can still only have one version of it. So either you've got to figure out which version works with both, or you're not going to be able to use that dependency. You can't have that nested stuff. Just one version, and that's it. And this, now we can go into this large rabbit hole of conversations around these things. And this is where the Go PM mailing list is really great. We've been having these discussions for about 2 years, all right? 2 years. And all of these same questions come up there. So definitely after this, we can talk more. That's a great place to have these conversations. But at the end of the day, you can only vendor that dependency once, one version of it, right there under that vendor folder, and anything else that's using it has to use that one.
But not with the but not with the 1.5 vendor experiment, I believe.
Yeah, I haven't gone into that level of vendoring with the tool yet.
More questions?
Hi there. What's the workflow for when you need to patch one of your vendor and submit an upstream pull request?
I'm sorry, ask that again?
Normally, you'd have your dependencies as separate checkouts, and you'd be able to send a pull request on GitHub to fix it. So what's the new workflow when you have it vendored?
Yeah, so I don't use the submodules or keep any of that stuff there. This is my own version of this code. So if I'm going to update it, I'm going to replace it with whatever the new code is, test and verify that it works, and then pull that back into my repo.
I'm just wondering, but you need to test it with your project, so you need to use the canonical repository for a while you make your pull request.
No, I can copy that code right into my vendor folder. If I don't like it, I can just not push that up, right? All right. I don't think I understand.
Okay.
We can talk
yeah,
after.
we'll talk. I'm just thinking about the flow for developers, because it makes it quite hard to contribute to open source projects with vendoring.
Oh, okay. I see what you're talking about. So this is not for, okay. This is my opinion. You shouldn't be vendoring packages that you're open sourcing. It's not your responsibility as a package author to worry about that. If you're building binaries, right? I'm building a binary that's going to go into production. Now it's my problem. Now I have to worry about vendoring. If you're writing a package for the open source community to use, then you can't do this. And you have a responsibility to make sure there's backwards compatibility with your API. And if not today, you have to then give this a new name, new repo, okay? Because you're breaking the API. But that doesn't apply here. This is just for the binaries that you're building.
Thanks.
Any more questions? No? Last questions of the conference? Come on, guys. Yeah?
Hi. So you seemed very excited about GB. So I was a bit curious what made you choose that particular tool as opposed to some of the others that take the exact same approach, like GoDep or Glide, or there was some others, I think.
So GB is not like anything out there right now. GB does not sit on top of the existing Go command. It is its own tool. It uses the compile and the link and the assembler to, and you have to build code. But it's not like anything that's out there. And that's why it's so successful right now in being able to not worry about these rewrites and being able to put that code anywhere we want and all of those things, because it's free from those constraints that the Go tooling puts on that other tooling like GoDeps and all those other ones. So that's why I'm really excited about it, because it was this initial idea of, look, we don't necessarily need to use the Go command to build our code. We can build our own tooling and do things in a way where we can have this reproducible build and even make it easier to manage the source code that we're coding in.
Okay, thanks.
Any more questions? No? Cool, thank you, Bill.
All right.